We have a big one and a smaller tank here, but we are in this experiment we only use this big one, and this is air pump, and this is the controller, and there's a data logger here. It can directly link to your laptop, and there's software. It can get the result directly from the software. It is called ArmSoft. Yeah, I already installed it on my laptop, and I can start. Yeah, you can also get readings from the controller here, and you need to switch the temperature one that is in this bigger one, and temperature 2 in this smaller one, and P should be the pressure in this one, and V I think is pressure in this smaller one, and
is the tank open to the atmosphere?
Yeah. At the beginning, we just open it.
So that pressure that says on the gauge minus 0.
Actually, it's 0.
That's just a calibration
Yeah.
error.
Okay, we'll load the first one, exercise A, heat capacity ratio on the software. Here. And now we can directly read the temperature on the screen here. It's a room temperature 26.5
degrees Celsius. The other tank is reporting 26.4 degrees Celsius, so there you go.
Okay, so the first step we just, because now all the valves are open to the air, and let me check it. Yeah, first one we just close valve, close all the valves. Yeah, this is just close all the valves, and we open the valve 4. This is the valve 4.
And I think they're numbered on
Yeah,
top of the
yeah.
apparatus, so I'll show it on the video. So there are
Yeah,
everything is pretty clearly labeled.
Yeah.
Valve
It's also
numbers.
wrote on the handout. Yeah, it's also there's a picture on the handout. And we will, let's see, just open the valve 4. That links to the air pump. And there's the air pump switch is here. I'll turn on it.
So we're pumping air in or out of that
In.
tank?
Into this tank.
So
Okay,
the way the
wait until it gets to about 30 kilonewton per square meter. Yeah.
So you can see
Yeah.
on the data logger 30 point something kilonewtons per square meter, or we would
Yeah,
probably
we
say
waited,
kilopascals.
yeah, because the temperature now increased and to 27.5. We wait, a few more minutes until it gets to the room temperature again. And we can,
So we've just seen some adiabatic warming in action.
yep. And now we can,
Of course, this temperature will decay.
mhm.
It will, I guess,
Yeah,
radiator
and the-
processes.
And the
as well.
pressure decreases. Yeah, because the temperature getting down, like it's getting cooled, and the pressure also just.
So why is the pressure decreasing? Are the valves
Because-
not fully closed?
Because it's cooling.
It's just cooling, that's
Mhm.
all.
Yep. It's
Very
not
nice.
diabetic. We can, yeah. And here, it asks you the atmospheric pressure, and I just set it to 1. 1 atmosphere pressure here.
1 bar.
Yeah, 1,100. And then I can wait until the temperature just to be constant. Yeah, get to the room temperature again.
So temperature is going down, the pressure is going down.
So there's the relationship between the pressure and volume. PV equals N times R times T. You get using that equation. And wait until it gets to constant.
And just to reinforce, the same measurements are also accessible right here from the controller. Right now it's reading pressure in kilopascals
turn it to
relative to
T1.
room pressure.
Yeah.
But if we turn the selector knob to T1, then we get
It's not so.
we get temperature, but in very strange units. Because it's actually a measurement from a thermocouple device that's here inside the tank, and the software is converting that to degrees Celsius. This is a bit harder to interpret.
Yeah. Okay, so now it get a constant temperature. So now we can start, and we just press the go button to record the temperature and pressure inside. I'll press go, and I press table, and we can get it record the change every 10 seconds, I think. You can, yeah, you can get yeah, you can see it's the elapsed time every 10 seconds.
Yeah, so we get a new entry in this table every 10 seconds.
Okay. And because you only use the tank 1, so you don't need to care about the readings of the tank 2. And you wait for a few more minutes. So now, when it's getting constant, we can just open the valve 1.
So just
Right.
let's take a quick look at this sheet. So the temperature is stabilized. The pressure is
You get the reading every 10 minutes, every 10 seconds.
Yeah. So it's still going down very, very slowly.
Yep.
Yeah. Okay.
And now we just open the valve for a very short time. Open it and close it. Close it. And to record the change, abruptly change here.
So our pressure changed very abruptly. But the temperature stayed the same.
Actually, temperature, I think it decreased because there's a suddenly pressure loss.
Well, that's not what the table's reporting.
There's what physics tells us, and there's what this data says.
Yeah, you can see the temperature
I'm looking
here.
at the wrong
Yeah.
column. I see. So forget what I said. T1, not T2. I've been reading this wrong the whole time.
Could you also plot this up as a continuous graph?
Yeah.
Visualize it?
Yeah, yeah. I think the software can do it. Actually, the experiment instruction, it asks students to do that, to make a plot. And wait until the temperature goes back, and it suddenly decreased from you see, from 26.6 to 23.4, and it goes back again. Right? So now when your temperature and pressure keeps constant, that means you can go to the next round. And now you can, let me see, you can press the stop. Then press the stop here. And the software can help you calculate the the heat capacity. It's the ratio of CP versus CV. You determine the heat capacity ratio. This is the constant pressure heat capacity, and CV is the constant volume heat capacity. And their ratio, so you need to get their ratio to get the heat capacity ratio gamma. That is what you need to get during this experiment.
And we didn't use it in this experiment, but the second tank is the vacuum tank, right? The
Yep.
way the air pump is hooked up. When we turn that pump on, if the valves are
Yeah, there's a valve here.
we'll be simultaneously pressurizing tank 1 but depressurizing tank 2. So the other experiments will
Yeah.
will use vacuum in addition to
There's a
excess
valve
pressure.
to link the tank 1 and tank 2.
So have you, after doing this experiment, have you done
Yeah,
the calculation? How
Actually, I didn't do the calculation
I'm just
because
curious
software
how well it reproduces the known
Well, it's
value.
giving us a gamma of 1.22.
Yep. And then you can just get to your next round, I think. Let's see.
I forget.
Press the next button. Then you can go to the next round. You just press the next button. You get the round 2. And you press start, and it gets the readings from the second round, and you can do it again. And you do it again and again and again. You can compare the ratio of CP versus CV.
And I wonder if it's precise enough that we might be able to do things like calculate, in drier versus moisture air conditions. I don't know if that is in any of the experiments that come with
There
this
are only 2
apparatus.
experiments they just designed for you, so you can design more experiments by yourselves.
The interior is it's like sealed up.
Mm-hmm.
Well, right?
Yep.
Would be a little concerned if you got it too wet in there. You got some condensation in there. It might be really hard to clean it out. It might get gross.
That's true. We don't have an easy way to open it up to do any cleaning. I'd like to think we could pump different gases in, right, to measure different gas constants, for example. But it's set up to pump air in and pump air out from the room, and we'd have to do some.
You can always draw this out from the second tank, from the tank 2. This is a vacuum tank, and you can open the valve to draw the gas from the tank 1.
Right. And so in principle, we could put some more plumbing in to supply other gas sources into one of the tanks.
Some helium.
We do have helium here in the lab, but that's for another day.